that for a given mass of gas at constant temperature, the volume of the gas varies inversely with pressure. As seen here, it definitely means that we're dealing particularly with temperature and pressure. Right now, we also know that if the temperature is constant, as the pressure of a gas increases, then the volume also decreases. Also, as the pressure of the gas decreases, the volume also increases. And then, of course, the mathematical expression of the Boyles Law is as follows. I already told you we have volume and temperature, and that's what we have. Pressure and volume being temperature is constant. Alright, the reason why we see these this way is that temperature remains constant while the volume will vary with pressure. Because temperature is constant, the combined gas law equation is simplified or treated as T1 is equal to T2, and it's just a unit which is simplified as 1. Example on Boyles Law. Here we have, while using explosive to knock down a building, the shock wave can be so strong that 12 liters of gas will reach a pressure of 3.8 times 10 raised to the power 4 millimeter mercury. And then when the shock wave passes and the gas returns to a pressure of 760 millimeter mercury, what will the volume of the gas be? You look at it closely again and you can see very clearly that 12 liters is mentioned, which is V1, of the gas will reach a pressure which is P1, and then when the shock wave passes, the gas returns into P2, you're going to be looking for V2. So using the formula, which is V1 and P1 equal to V2 P2, then you have V1 as 12 liters, and then you have P1 as 3.8 times 10 raised to the power 4 millimeter mercury, and of course you have P2 here as 760 millimeter mercury, and we're looking for V2 as shown in the data. And so where we have all of these, the next thing to apply is your formula. So if you have P1 V1 is equals to P2 V2, then you should have that. These multiplied by these will equate V2 and this. So we're looking for V2. Right now where we have these constants here and we've replaced the values with the figures, and then you can solve for V2, which is what we're looking for. Solving for V2, then we can have this formula replaced here with 2 liter, which is 12 liters established here, multiplied by 3.8 times 10 raised to the power 4 millimeter mercury divided by 760 millimeter mercury to look for V2. So multiply these in your calculator and then divide these, and definitely you have an answer which is 600 liter as your second volume. Charles Law. Charles was another individual who worked on gases and stated that the volume of a fixed mass of gas is directly proportional as opposed to Boyles' law where he said it was inversely proportional, but this time directly proportional to its Kelvin temperature. So if the pressure is constant. So you see what is constant here now is pressure. So our formula has to be between volume and temperature, which gives birth to the formula. So as the temperature of an enclosed gas increases, the volume increases if the pressure is constant. So as the temperature of an enclosed gas increases, then the volume increases as well if the pressure is constant. Having that behind your mind, the mathematical expression for Charles' law will definitely be that temperature must be in Kelvin 1. And then of course the formula should be V1 all over T1 is equal to V2 all over T2. So then we now apply these in several problems, and then we'll have just a problem here which has to do with 1. The temperature inside my refrigerator is about 4 degrees Celsius, and if I place a balloon in my fridge, which is strange, that initially has a temperature of about 22 degrees Celsius and a volume of about 0.5 liter, very small, there will be a volume of the balloon when it is fully, what will be the volume. So we're looking for V2 when it is fully cooled by my refrigerator. Have you placed the balloon before in the fridge? You could try it sometime and do a little bit of calculation. Then our first V1 here is definitely going to be 0.5 liters. And of course we have two temperatures, T1 and T2, which will be T1 22, and then of course T2 and V2 all place. So if we have the first temperature 4 and then the second temperature, which is this, and then we're looking for V2. To do that, you have to use the formulas again, but the temperature must remain in Kelvin. So look at this. Is it in Kelvin? No. Is this in Kelvin? No. What do we do to both of them? We have to add 273 to both of the temperatures to get it in Kelvin. And so because of that, we say 22 plus 273 to give us 295 Kelvin. And of course, 4 degrees plus 273 to give us 277 Kelvin. Right, having all these in place, then we can use the formula for Charles' law, which states that V1 all over T1 is equal to V2 all over T2. And looking at these already, we know we're looking for V2, which is the second volume. So we'll make V2 subject of the formula by saying V2 is equal to V1 multiplied by T2 all over T1. And so V2 will be equal to, definitely, what is your V1? Alright, so looking at these, then we have that the first volume is 0.5 liter, and then the first temperature is definitely going to be 295 Kelvin, and then you're looking for the second volume, and then T2 is 277 Kelvin. Having these behind your mind, the first volume will be 0.5 multiplied by T2, as shown here, which is 277 all over T1, which is 295. V2 will be giving you a value of 0.47 liters as your final answer.